Good morning, guys. Well, I guess it might not be morning when you're watching this, but it's 7:45 on Friday as I'm taping it. Taping? It's not taping, I suppose. Recording? Anyways, we are getting started on section 1.3, evaluating limits analytically. And I feel like this is where calculus kind of starts to get fun. We get to do a little bit more algebra with this, and it's a little bit more thinking, I would say. So I am looking forward to teaching this. So first, we're going to go through some properties. I actually went ahead and wrote them down because it's just a lot of writing, and I will make it a tiny bit smaller. And so that way, if you want to pause the video and jot these down really fast, just so you can follow along, there's not a whole lot of writing once you write the questions down. So to make the video a little bit quicker, I went ahead and jotted these down. So this would be something that would help for you to put in your notebook. We will be using these properties on and off throughout the year. So we have, in green, I wrote down the properties, and it's kind of more math, like they're all variables, even though that B looks like a 6, that's really a B. So that's all in variables, and then I'm going to give you a numeric example as well, because I feel like seeing it with numbers is sometimes easier than seeing it with letters. So I have here, suppose that the limit as x approaches c of f of x is equal to L, and that the limit as x approaches c of g of x is equal to k. And we have some properties that are just true. So these are things that I'm telling you that are true. If I want to find the limit as x approaches c of some number b, so that's a constant, so it's not a variable, but some number b times f of x, then since I know that the limit as x approaches c of f of x is L, I can just take L and multiply by b. Meaning, and let's take a look at the example over here, and I'll do this in a different color actually. Let's change to pink. I'll put all of the answers in pink so that helps you out a little bit. So for my example, I'm telling you that the limit as x approaches 2 of x squared is 4, and the limit as x approaches 2 of x cubed is 8. So if I ask you for what is the limit as x approaches 2 of 5x squared, well, since the limit as x approaches 2 of x squared is 4, it's going to end up being 5 times 4, which is just 20. In the next example, it says that if you were taking the limit of two functions added together, you can just add the individual limits or subtract them if it was subtraction. So this would be L plus or minus k, meaning that if I want the limit as x approaches 2 of x squared plus x cubed, I just want to take the limit as x approaches 2 of x squared and add the limit as x approaches 2 of x cubed. If we are multiplying two functions inside of a limit and taking the limit of the product, then the limit as x approaches c will end up being the product of the limits. So L times k. So for instance, if I want the limit as x approaches 2 of x squared times the limit as x approaches 2 of x cubed, that's going to end up giving me 4 times 8, which is 32. The next property is the limit as x approaches c of f of x divided by g of x. Well, as long as the bottom function isn't 0, you can just divide the limits. And of course, we can't let the bottom function be 0 because we're not allowed to divide by 0. So this property wouldn't hold true if the bottom was 0. And similarly, if I want the limit as x approaches 2 of x squared divided by x cubed, I'm going to take the limit of as x approaches 2 of x squared, and then put that over the limit as x approaches 2 of x cubed, which would be 4 over 8. Of course, we would reduce to 1/2. And finally, if you have a function to a power, and you are taking the limit of that function to the power, it would be the same thing as taking the answer to the limit of the function and raising that limit to the power. So this would be like L to the power of n. So the limit as x approaches 2 of x squared is 4, and then I can raise that to the 5th power since my function's being raised to the 5th power. For the third is 64, so 256, 1024. That's 4 to the 5th power, and of course you could type that in your calculator if you needed to. So now we're going to do a couple of examples, so if you need to pause to jot these down. That's completely fine. But again, they're kind of quick examples, so I went ahead and wrote them down. I won't always write them down ahead of time, but this is something more where it takes longer to write the problem than it does to do the problem. So if you want to pause, write this down, that's great, but I'm going to go ahead and get started. So we have the limit as x approaches c of f of x is equal to 3 over 2. And then the limit as x approaches c of g of x is equal to 1 over 2. So I want to find the limit as x approaches c of 4 times f of x. So I'm going to take that 4 and just multiply it by my limit. And we know that 4 times 3 over 2 is just 6. The next one, we have the limit as x approaches the limit as x approaches c of the cube root of g of x. Well, we know that this is the same thing as a power. So if you remember from previous math courses, this is the same thing as g of x to the 1/3 power. So that means that I can treat radicals just like I can powers. So this limit will just be the cube root of whatever the limit of as x approaches c of g of x was, which is 1/2. Now we know that the cube root of 1 is just 1, and the cube root of 2 will stay on the bottom. So something that you will find that is different than previous math courses is I do not make you rationalize the denominator. You can, it would never be considered wrong if you rationalize it, as long as you do so correctly. But as long as you get to the final correct answer, I do not consider needing to simplify this radical part of the question, so you could leave it just like that. Usually when I'm teaching this, I usually have some very happy students at that point, and now I don't get to hear how happy you are since I can't hear you learning. Number 3, we have the limit as x approaches c of f of x divided by g of x. So I'm going to take my limit as x approaches 3 of f of x and divide that by g of x. So although I consider radicals in the denominator okay, you are never allowed to leave fractions inside of fractions. So this you would need to divide. The nice thing is, since the denominators are the same, you just end up with 3 over 1. And finally, we have the limit as x approaches c of 2 times f of x plus 8 times g of x, which will just be 2 times 3 over 2 plus 8 times 1 over 2. 2 times 3 over 2 is 3. 8 times 1/2 is 4. 3 plus 4 is 7. So I'm going to stop there. I hope that this helped you understand the properties of limits better. And if you have questions, please send me an email.